All right, hello, Jack and Tate. We're starting R6. This is the homework problems for R6. If you need to pause, go for it and write these down. But you will need to get these notes from me. Unless, is somebody gathering Jack and Tate's assignments? No? Okay, all right. Okay, so if you want me to send them with somebody, I can. But, yeah, you'll have to get these notes from me. R6 is numbers and more quadratic equations. Okay, so we start, they introduce us to like imaginary numbers or complex numbers, and a lot of times we have imaginary numbers when we do quadratic functions. Okay, so for example, like let's say we're doing the quadratic formula and we have negative b plus minus square root. You don't have to write this down, just follow along. B squared minus 4ac all over 2a. This guy inside of here, does anybody remember what he's called? It starts with a D. Discriminant. Okay, and the discriminant, if that number turns out to be negative, which it totally can, you would have a square root of a negative number, which we know can't happen. That leads to an imaginary, right? Okay, now what do we use the quadratic formula for, to find for us? The zeros. So if the zeros are imaginary, what does that mean?
Not there.
He's not touching. He looks something like this or something like that, right? Like he wouldn't touch in that case, okay? Which is totally like that happens, okay? So that's kind of what we're looking for. And we're looking at, in this section, how we simplify those imaginary numbers to make them still look kind of like decent.
So
And then uses of them. What?
Imaginary can't be graphed.
Imaginary just means there isn't one. So like here, when we do this quadratic formula, we're trying to find the zeros, okay? And if the zeros are imaginary, that means there aren't any zeros. Does that make sense? He doesn't cross. Yeah. Good question. Okay? All right. So let's move on down here. The two main things that I want you to remember is that the square root of a negative 1, that's what I is. Okay? So really, if you have like a negative inside of a square root, you're just going to pop him out as an imaginary number because it's like dividing by negative 1. Okay? Now, if that's the case, check this out. If I is equal to the square root of a negative 1, and let's say I square both sides, trying to get rid of the square root, right? I get rid of the square root, I squared will be equal to just negative 1, right? So if I have like big multiples of I, like I to the 7th power or I to the 151st power, I can reduce that down knowing that I squared is equivalent to negative 1. Got it? And we'll do some of those here in a second, okay? So like here, they just said like if you have the square root of negative b, it's I times the square root of b, okay? So like the square root of negative 4 would be I times the square root of 4, which then is like 2I, right? Because the square root of 4 is 2. Got it?
Yeah.
I times 2 or 2I, yeah? Does that make sense? Okay?
Well, then A would be 5I.
What?
He's working on
You betcha. Yeah, look at that. Okay? So the square root of 25 is 5, and the square root of a negative is I. So there's I. Now, do we put plus and minus in front of the 5I?
No.
No, because the square root was already there, right? If we insert the square root, then we do, right? Even though it's imaginary, we still put plus and minus in front of it because it just, that's what we do. The square root of 12 doesn't come out nicely, okay? So I know that he's going to have an I on the end of him, right? So I'm just going to make him I. And 12 can break down into 4 and 3, and we take the square root. What's the square root of 4? 2, and the square root of 3, and where do you want to put the I?
In between.
You want to put the I in between? Some people put the I on the end, okay? But just make sure that if you put them on the end, make sure it doesn't look like your little bar comes across him. Does that make sense?
You do 2I squared.
You can do 2I square root of 3, you betcha.
Can you do
Yep.
I2 square root of 3?
Technically, but like I2 is kind of like X2. Like 2X or X2, Like that just looks weird,
Look right.
So technically, I mean,
This
that's
looks like
okay, but
X squared too big.
either one of these would probably be the best.
I would just
Okay? I mean, yeah, you're right. Like, technically it's legal. Okay, what about the square root of 13?
same thing.
Just leave it.
Same process. Square root of 13.
Square root of 13, I is prime, or excuse me, 13 is prime. You cannot reduce 13, so you just stays the square root of 13i. Perfect. Got it? Not too bad. All right, now I love these. These are my favorite. Are you ready?
Wait, square root of 13i?
Square root of 13i.
Can you do
this guy
I
up
square
all
root
the
of
way.
13?
Yes. You can do I squared to 13. Okay? All right, let's do this one. I'm going to go off to the side over here, and I'm going to show you in reduced form. Okay? Let's do I to the 4th power, I to the 5th power, I to the 6th power, I to the 7th power. I'm just going to do all of those because this is going to cover all of the possible answers. Okay? I to the fourth, I to the fifth, I to the sixth, I to the seventh. Got it?
Got it.
Okay. We don't know what any higher powers are other than I squared, right? So I'm going to write everything in terms of I squared. So I to the fourth is like I squared. Whoop. I squared squared, right? Got it? This is like I squared squared. Okay, but what did we say I squared was? -1. So this is like -1 squared. If I take -1 and square it, is it -1 or +1? +1. That's my final answer. Okay? Let's skip over to number 6. This is I squared cubed, right? Are you guys following? So this guy is -1 to the third power. If I take -1 and cube it, he will be -1. Okay? So let's look at trends here. Odd numbers are going to reduce to 1 or -1. If it is a multiple of,
Odd numbers or even numbers?
excuse me, even numbers. I'm sorry, even numbers. Thank you for correcting me. Even numbers are going to reduce to 1 or -1. If it's a multiple of 4, it's going to be positive. If it's not a multiple of 4, it's going to be negative. Does that make sense?
Even equals positive or -1?
Yep.
Wait.
If it's a multiple of 4, it will be a +1. If it's not a multiple of 4, it's a -1, right? 4 is a multiple of 4.
4 equals.
You don't have to remember these rules or write them down unless you want to. Okay? Even equals plus or -1. Multiple of 4 equals +1. Non-multiples of 4 are -1. Got it? All right, now what do we do if we have like 5 and 7?
Can we just I times I? So
Yeah, so here we're gonna hang an I off, okay? We're just gonna let an I dangle there, and then we're gonna do I squared, right? This would be I squared, which would be I to the fourth, and then we're gonna tack on another I, right? Okay, so we just figured out how to do this one.
So it's 1 I.
This would be -1 squared times I, and -1 squared is 1, so this is just 1I or just I. Do you see that? Questions about that? If it's an odd power, you're going to hang an I off. Okay? Do you think it's going to be -I? Okay, we'll see. You're right. We're going to hang an I off, but this would be I squared cubed. The only thing that we know is I squared. We know I squared is -1. So -1 to the third power times I is going to be -I. Every single time you do this, it's either going to be one of those 4 answers. The only time it's not one of those 4 answers is if, let's say, he had like a 4 out in front here. Then you would have to take that whole thing times 4, right? Okay? But every single multiple of I is going to reduce to 1, -1, I, or -I. Got it?
Hang on, don't we? So how do we like establish the 5 from the 7?
Okay, the 5 from the 7.
Yeah. How do we do that? How do we?
If it's 1 more than a multiple of 4, then it's positive.
Okay.
Like 5 is 1 more than a multiple of 4. So if it's a multiple of 4 plus 1, it's going to be positive I. Right? That's confusing.
So just a tad.
Just a tad.
Okay, 49.
Okay. What?
I.
What? Which one? What are you talking about?
49. I'm just saying. So 40.
Oh yeah, 49 would be I. Yeah. See, look at you go.
48 is 1.
48 is 1.
Yes.
Yeah, because he's a multiple of 4.
1.
Got it? So I to the 48. So you guys just said this is a even number and a multiple of 4. Since it's a multiple of 4, it's going to be positive 1. But let's show you how. If you don't, I don't know why I'm doing that. We only know I squared. How many times do I take I squared times itself to get 48?
Good question.
24. 2 times 24 gives you 48. But we know I squared is -1. If I take -1 times itself 24 times, I get positive 1. There you go. So he reduces to positive 1.
1.
Got it?
24th power. What? 1? 1 greater. It's 1 greater.
Okay. Good? Happy with that?
Yeah.
23. We're going to have to hang an I off to the side, but then we have I squared to the what? I squared to the... We have 1 I over here. We need... Somebody said it.
I thought
Ethan said it.
18.
Maybe.
We're going to 18.
No?
Nope.
Then it was Billy. I can't tell. Who said it?
Was it 22?
It was Carter. It was 11. Who said 11?
I did not say 11.
Somebody said 11. I thought it was a boy coming from that direction. But anyway, okay, does that make 23? 2 times 11 plus 1, is that 23? Yes, okay. -1 to the 11th power is -1 times I is -I. Okay, if he's odd, you hang one off and you figure out how many more you need.
I like these.
Okay, all right. C. Is it a multiple of 4?
No, but it's
No,
even.
so it's going to be negative. But it's even, so it's going to be -1. Let's see why. So, I squared to the what power?
25th.
25th. 2 times 25 gives me 50, right? I squared is -1. -1 times itself 25 times is -1, just like we said. It's an even number, so it's going to be 1 or -1, but since it's not a multiple of 4, it's -1.
Whoa.
Because only when it's an odd number do you have to hang an I off. Does that make sense? Otherwise, all the I's go away. Okay, did that answer your question? Yeah? Okay. All right, D. This is tricky.
1 over negative I. That's what I got.
Okay. Okay, we'll talk about that here in a second. Negative exponent is 1 over, right? Like we have to make it into a positive exponent, so 1 over I to the 19th power. Got it? Does that make sense? 1 over I to the 19th power. You flip him to the bottom. Does anybody not understand what I just did? Okay? All right, now let's do I to the 19th power to see what he actually breaks down to. We have to hang an I off, right? Because he's odd. Okay? Then we have I squared to the what?
9.
To the 9th. 2 times 9 is 18 plus 1 is 19. Yeah?
I
Okay?
squared to the 9th power.
2 times 9 is 18 plus 1 more is 19, right?
Okay, yep.
Okay? All right. I squared is -1. What happens when we take -1 times itself 9 times?
-1.
Still stays -1 times I. What's -1 times I? -I. So my final answer, almost final answer, should be 1 over -I. Yeah?
No.
Except,
You like it?
you guys are going to hate this.
I'll reprint that.
Are you ready?
Okay.
You're going to really, really hate this. I on the bottom is like having a square root on the bottom. You have to rationalize it.
What?
You have to rationalize I's on the bottom. I's on the bottom is considered improper. So what's the what would the conjugate of -I be? What's the conjugate of -I? Positive I. So I'm going to take him times positive I over positive I. Yeah? The conjugate of -I. This guy is bad. We don't want a negative, or we don't want an I in the bottom. Okay?
Wait, so 1 over negative 1.
Okay? All right, so are we good to this point? Do you see why we're taking him times I over I? Okay, we don't want the I in the bottom. All right, on the bottom now.
Wait, is that right?
If we multiply him -I times positive I, it's -I squared. Got it? Okay? On the top, what do you have? I. Okay, now, what is I squared? -1. So I have -1 on the bottom,
Oh, it's 1.
which is +1. So I have I over +1, which is just holy bejeez.
Why?
Why are you
That's a
guys
lot.
doing the same?
What?
Why are
Kinda
you doing
lame.
the same?
Why is it a thing? I have no idea.
So dumb.
I don't know.
It could have been something
Okay,
so -1. I. Okay.
Yeah.
That was
Okay, they don't like I's in the bottom, so we have to get rid of them by multiplying by the conjugate.
Lame up.
no. Wait, so no I on bottom.
No, we don't want I's on the bottom. Just like square roots, we don't want square roots on the bottom.
On bottom.
Right, we did those where we took the square root out of the bottom.
Oh yeah.
Yeah.
Yep, we did that.
Okay.
Mhm.
This is Reese.
Okay.
This is the only one you have done.
Good? What?
Yeah.
Our own negative exponent.
That's the only one I've done.
No.
It's really
No.
easy.
It's only I if it's an odd
Just by-
exponent.
So do you have to always just that? Seeing my face on that.
If you end up with an I on the bottom, yes.
It's kind of funny.
If you end up with an I on the bottom, yes.
You can't have even a
Come on,
positive I
True.
on the bottom.
Yes.
I did Josie.
Cringy.
You did who?
Josie.
Let me see it.
No.
All right.
It's kind of funny.
No passing notes in class.
Nothing on it but a picture. Calm down.
There's a few words.
Okay.
Oh my god.
What do they say?
All right.
Judge.
Here's the easy part. We're ready for this one. This is going to be easier than that. Okay. I don't know why they didn't put this part first.
Wait,
Here
do
we
combine-
are.
Do we combine like terms? Like
Yeah.
I-
We're doing complex numbers. Okay. Complex numbers will have a real part and an imaginary part. So like this guy right here, 5 minus 7i. The imaginary part is the negative 7i. The real part is the 5. That doesn't have an I, right? Real versus imaginary. And together they make a complex number, okay? Now, we have, like, let's say we were dealing with, like, 6i. This is something called a pure imaginary number. Because what's his real part?
Oh wait, he doesn't have a real
I.
0, right? This is like 0 plus 6i, okay? 6i would be like 0 plus 6i. So his real part is 0. The imaginary part is 6i. So he's a pure imaginary number because he doesn't have a real part. Does that make sense?
So he has to have a number with.
He's fake.
The number without the I is the pure part.
Yes. No. The number without the I is the real part.
Oh, is the real part.
So if he doesn't have a real part, then he's a pure imaginary number because he only is imaginary. He's an only imaginary number. Okay?
Without
Makes
I
sense?
Equals real.
They didn't even give that to you, so they probably aren't going to ask you. But just so you know. Okay?
A real
All right, next. They want you to write the answer in the form of A plus BI. We're combining like terms. We have 3 pieces. Do you see the 3 pieces? 1, 2, 3. Okay? Negative 2 minus 4i. He's just chilling. The plus 5 plus 2i. He's just chilling.
So can we just like
But then we're going to distribute the negative through, right? This would be minus 3 plus 6i, and now we're going to combine like terms. Ah.
4I plus.
Okay, let's do the real part first. We have 3 real numbers. Negative 2, 5, and negative 3. 0. Negative 4i plus 2i plus 6i is
Negative 2 plus 6 is what?
Negative
4?
four.
Positive just 4.
plus
4i.
4i.
pure imaginary number?
That's a pure imaginary number, so 4i. Okay? You can either put 0 plus 4i or just 4i.
What are you looking for here?
Just combining like terms.
You're looking for the to get it. Wait, what? Wait, so if they wanted an A plus BI, then we leave the 0 on.
Yes. Oh, technically, yeah. If they wanted an a plus bi, technically we leave the 0 on the end there. Right? If they want it in the form of a plus bi. 0 plus 4i. Yep. Okay? So we're going to leave the 0 on. All right, this guy, what is he asking you to do?
Do the same thing.
You're multiplying, right? Because these 2 right here are right next to each other. So it's like a foil, okay? All right, so negative 2 times 4 is negative 8. Negative 2 times negative 3i plus 6i. These are just like x's and y's, except until the end. 6i times 4 is plus 24i, and 6i times negative 3i. Negative 18i squared. Did you get that that last piece? Yeah, we're going to fix him here in a second, okay? All right, so before we start combining stuff, we know that I squared, we did this in Algebra 1, did we? Or Algebra 2, did we not?
We did it somewhere. and
Okay.
I didn't understand
I
it.
squared is negative 1, right? So negative 18 times negative 1 is actually plus 18, true? Now we combine like terms. Negative 8 plus 18 is 10 plus, what's this guy?
30i.
30i, beautiful, there he is.
Where'd you get?
Okay,
Oh, okay.
okay, questions?
Hang on, so it's 10.
You stop and I'll back up and explain. Are we doing okay? Anytime you have I squared, which you will always get an I squared if you're multiplying 2 complex numbers together. So that I squared, just flip the sign of the original, like of the term, right? This negative 18 became plus 18. No I's, right? There he is. Okay. We got a little bit left.
We can go to example 6.
Okay, we'll do a little bit more.
Maybe example 4.
Okay. Okay, example 5. A, write the results in A plus BI form. Okay,
We got a foil.
this thing. We can't just square each piece because this actually means 3 plus 4i times 3 plus 4i. Do you want to try it on your own?
Yes.
Are these conjugates?
No.
No. Will the middle 2 pieces cancel?
No.
No. Okay, try it on your own.
24, 16. Yeah. Right? Oh, yeah, yeah.
Okay, as soon as you're done, check yours with me.
9 minus 60. Minus 60.
Let's go.
You get it?
Negative 16 plus 9 is negative 7. I don't know.
Reese, did you get negative 7 plus 25?
Okay, I see that now.
Yeah, so yeah, you just combine on the same side. So it's 39 minus 16, so that would be negative 17.
But then we do we have to, for
Okay.
for this part, do we have to do plus 0i?
Technically, yeah, if they wanted an A plus BI form. Okay. Did you guys get A? Did you get it? Negative 7 plus 24i? They wanted an A plus BI form. Okay. So B, this one is
Oh, we can
conjugates, right? The middle two pieces are going to cancel out. So you don't necessarily have to write them if you don't want to. I'm going to. 5 and 5 is 25. 5 times negative 2i is negative 10i. But then we have plus 10i. So if you want to just skip that step, you sure can. What's 2i times negative 2i?
4i.
Minus 4i squared. Okay. The I squared becomes negative 1. So that minus 4 is going to become plus 4. So the answer is 29. If they wanted an A plus BI, we need plus 0i technically. If they wanted an A plus BI form, we have 29 plus 0i.
Now we need to figure out how to do this.
Got it? Good, good.
I think this is easy.
Okay, this is nice.
How
This
is
is
it
nice.
hard? This is
Physics?
easier.
Physics is killing me right now.
Physics is easier than chemistry.
No, it's not.
All right, what time are we at out of here?
Have you done today's
42.
assignment yet, Joe?
Not yet, no.
Okay.
Okay, this is example 6. This is like the square roots. We don't want i's in the bottom. We don't want square roots at the bottom.
Yeah.
So we need to multiply by the conjugate.
Okay, can you
Conjugate
go
at the
up
top or the bottom?
a little bit?
Bottom.
It's really blurry.
It's really
Oh,
blurry.
it's the bottom, right?
So is today basically the same thing we just did except with
Kinda,
eyes?
with i's, yeah. Yeah. So we're gonna multiply by what?
3 plus 5.
3 plus 5i and 3 plus 5i. And because I'm multiplying the top and the bottom, I'm really just multiplying it by 1, which only changes what it looks like, not what it is, right?
Yeah, for sure.
Okay, for sure. All right, let's FOIL the top.
24.
Do you want to try it on your own?
Yes.
Yes? Okay, I'll let you go then. You try. So don't look at mine until you're done.
Oh, you want us to do both of them?
Yeah, do the top and the bottom.
You do the bottom.
We FOIL the bottom
They
too.
cancel out. Yes.
See, this is where you lose me because I thought by multiplying by the conjugate on the bottom we didn't have to do a bottom because it canceled. Is that not true?
Oh, I can't do that.
Like if you take the bottom,
You don't
multiply it by its reciprocal, then don't they cancel so we don't have to write anything on the bottom?
No, the middle two pieces will cancel, but you still have to take the F and the L will still be there. The O and the I will cancel.
Hey, I got it.
O and I of your FOIL will cancel.
So there should be 9.
Homie, how do we do this, guys?
But that's not the right answer.
That isn't? You can divide. Can you do that? I didn't use this. Oh, we can divide.
This is just I times
34.
6i.
Okay, right? I can split it up. Can I divide by 3?
squared.
So negative 6. So I have done that before.
Make sense?
So then it's 24 plus.
Okay, did you guys get to that far?
There we go. I
But he's not
divided
done
it by
yet because all 3 of those parts are divisible by
The answer was 6?
2.
Oh.
Negative 6. So if I divide by 2, I have 7 plus 23i over, is it 17? There he is. 7, 23, and 17 are all prime. So we're done.
Okay, cool.
Okay,
I need to write
good?
that down.
Hang on, no, not good.
What?
I can deal with that.
Here. What's 9 plus 25?
What?
Shall we stop there? You want to stop there?
What lesson are we
Don't
on?
do the rest of
Should we stop there?
Yeah.
Okay, we can stop there. That's fine.
Go pretty far on our homework.
You can go pretty far. Dividing complex numbers. You should be able to get to
I think we can go to 54.
7 plus 23i over
I
17.
did something wrong.
Dividing, I'll come help you in a second.
We can go to 54.
Dividing complex numbers. All right, on your book. Dividing complex numbers.
Ew.
Nope, that's not what we want.
Can you go back to the problem?
Solving quadratic equations over the set of complex numbers. You can go to 56, but I probably don't give you a 56.
You give us a 54.
Okay, yep, you can get through 54. That's where you can stop. 8 through 54, those guys. Okay? Good? You can get through 54. All right, bye whoever's watching this video.